Hey, my name is Andy Soffer. I work at Google on the C++ core libraries team. We're responsible for maintaining Absel, Google Test, and like a whole bunch of other internal libraries. And it's one of those that I want to talk to you about today. If you want to follow along, you can find my slides here. The link is also available on the conference schedule, so you don't have to copy that very quickly. So I submitted the title for this talk before I knew exactly how I wanted to format it. And it's an accurate title, but it also could have been called How Not to Design Dinosaurs. And this is a reference to Jurassic Park. If you haven't seen Jurassic Park, I apologize. Some of the memes sprinkled throughout the talk are going to be, well, they'll all be Jurassic Park themed. So they might not be meaningful to you. But there's a famous line in which Jeff Goldblum's character says, "Your scientists were so preoccupied with whether or not they could, they didn't stop to think about whether or not they should." And I don't know about you, but this is a pattern that I fall into a lot. I get excited about some new language feature and I think, oh, like, what can I use this for? And I should really be thinking about the problem I'm trying to solve rather than the solution I'm trying to apply. So when I refer to dinosaurs, I'm talking about libraries that are really clever and interesting, like sort of as science experiments, but ultimately might be dangerous or difficult to use properly. So this talk is actually two things. It's a talk about a Mixin library, and we're gonna dive into the details on this particular Mixin library. But I also want to use that library as sort of a case study to think about the process that helps me think about design so that I don't design dinosaurs. So this is the plan for the talk, and it's basically structured in the way I think about design. So the first thing is, like, what problem are we trying to solve, and why are we trying to solve it? Right? This is important both to think about sort of internally in your own head, but also to articulate. Because if you can't articulate what the problem is and why it's important to solve, you're never going to convince anybody at your organization that this is actually worth solving. Once you do that, the next thing you need to be thinking about is, what are your priorities? Right? You're never going to design something perfect. There's always going to be tradeoffs. And so you want to actually make sure that you can articulate what your priorities are so that when you have to make those tradeoffs, you're doing it sort of mindfully. Now, if you're familiar with mixins, either in C++ or any other language, these two steps should be like somewhat familiar to you. You sort of already know what the answer is for what the problem is that we're trying to solve. But bear with me because we're actually going to go through that. Once you do that, you start to evaluate the design space. You look at what other people have done. You look at other languages. And this is where you start to make some design decisions. There's a lot of subjectivity here, but you're sort of starting to narrow in on something that's going to help you solve your actual problem. And you implement it. Steps 3 and 4 here, I've separated them out for the talk, but they do kind of really, they kind of go together, right? You can't totally evaluate the design space and decide what you're going to do unless you actually start implementing, and vice versa. And then once you do that, you're never going to get it totally right on the first try. You're going to get user feedback. And so you want to make sure you take that feedback into account and you iterate. I would be remiss if you came away from this talk thinking that this was all my work. Couldn't be further from the truth. So in reality, this is the culmination of tons of discussions and design and implementation work from many engineers. The people I've listed here are just the people that have contributed really to the design of this thing. There's a ton of other engineers at Google who have helped with bug fixes or other implementation improvements. And I want to call out Z Weaver in particular. She's sitting in the back there, and she's done a huge amount of work on this and is responsible for the migration of an existing library to this one. She's speaking immediately after this, I think, in this room. And so if you're interested in learning about what I'm pretty sure is the most complex large-scale refactoring that has ever been attempted in C++, I'd encourage you to attend her talk afterwards. Okay, so this is a talk about mixins, right? So I think I'm contractually obligated to show you a picture of ice cream at this point. But I'm not going to do that because even asking the question, what's a mixin, is getting way ahead of ourselves, right? If this goes to talk to you about the design process, well, we need to start with the problem, and mixins are the solution. Like, spoiler alert, they're going to be the solution, but we can't start there, right? We have to start with the problem. Okay, so what's the problem we're trying to solve? This is the problem we're trying to solve. If your eyes if you can read this, like your eyes are much better than mine. This is intentionally small. You're not supposed to read this, but I'm going to walk you through it. The point is that there's a lot of code here that is sort of small, it needs to be small to fit on one slide. So this is a struct called person. It's got two string fields that represent the two properties that every person has, a name and an email address. And that in and of itself isn't really enough to do anything useful with when you're programming. And so we have here a defaulted operator equals, so you can compare these people. We have a specialization of stood hash, so that you could put them in unordered containers. Specialization of stood less, so you can put them in ordered containers. We have like an ostream operator, a toJSON function, right? And these are sort of like the basic things you're going to need to do anything interesting with a person. And the thing is, this is the interesting part, right? Like these 4 lines, and I've of course highlighted that last line with the brace and the semicolon, right? There's not actually that much interesting here. This is all the stuff we have to write to actually like make anything happen here. And it's basically just noise, right? Like it's not that this isn't important, it's just uninteresting, right? If I'm hashing, I'm going to combine the hashes of the 2 fields. If I'm ordering the thing, I'm going to compare the first field and then compare the second. So each of these, you sort of just do the same thing with all of the fields and then combine them together. And it's the same process over and over again, and yet we have to write it by hand. Now, this is not a C++ specific problem. Here's the same code, or the equivalent code in Python. So again, we have a class person with this name and email field. And once again, the interesting part, the important part is up at the top, these 4 lines, right? But we still have to write all of this if we want to actually get anything done. And so we have to write all this repetitive code, and we have a word for this problem. That word is boilerplate. Boilerplate is a problem for both code readers and code writers. Right? For writers, the problem is that it's easy to make copy and paste errors when you do this. Right? It's also hard to keep things up to date as your surrounding code sort of inevitably changes over time. And for readers, this is sort of just noise that they have to look through. Right? It takes away their attention from the actual interesting problems. So this is a picture of actual boilerplate. This is rolled steel that you use to create like sort of the outside of hot water boilers. And of course, this has absolutely nothing to do with the way we use the term boilerplate today. And that's because it's not just a borrowed term, it's a twice borrowed term. When we talk about boilerplate, we're actually referring to these. These are printing plates that were used sort of in the early days of newspapers. And they look a lot like boilerplates, I guess, with the rough edges for the text, but that's sort of where the term got borrowed from. So when these were when people were writing newspapers, they would sort of print the text these blocks. They look like boilerplates, and that's what it got called. But still, like, what does that have to do with boilerplate? And the answer is, in the early days, you couldn't just, if you wanted to like syndicate content, right? You couldn't just email a PDF of everything like around the country. And so what you do is you'd assemble these plates and you'd physically mail them across the country. And that would take weeks, right? For it to go from like New York to Los Angeles or something. And so you would never print anything time sensitive or important on these plates. The only things it would ever make sense to put on these plates were sort of fluff pieces, filler that was just like not really important for anybody to look at. And so the text on this became known as boilerplate text, and that got borrowed into both the legal world and computer science. And so this is where the term comes from, is that this is like the filler material that nobody really cares about. Okay, so this is the problem we're solving, right? We're solving this problem of boilerplate, and the reason we're solving it is because it reduces readability, it creates brittle code, and generally just like slows down development speed. So at this point, you might be tempted to start thinking like, all right, like we know what the problem is, let's start designing a solution. But we're not ready for that yet, because we haven't articulated what our priorities are for design. Right? No solution is perfect, and our design is going to like encounter a bunch of different trade-offs, and we need to make sure that we know how we're going to like take care of those trade-offs. There's going to be compromises to make, and we want to make sure that we can do that and articulate that to our users. The good news is like this step of talking about your design priorities, they're usually things that carry over from project to project. And so you really only have to do this once, but we're going to go through it. So in 2019, Chandler Carruth and Titus Winters gave their design priorities for C++. There's a lot in here that generally matches my own design priorities. So I think this is a good place to start. And I want to focus on 4 of these today. So first of all, I care about evolution. And that's evolution for both the library author and for the library user. Right? For authors, they should be free to make improvements to their library. They shouldn't be stuck based on how the thing is used. But more importantly, evolution for the user. User code is going to change over time, and they shouldn't be locked into any sort of all or nothing situation. Small changes in their code shouldn't mean they have to entirely give up on using this library, right? They should be able to pick and choose the pieces of the library that make sense in their context. Second, I care about understandability. All else being equal, I want libraries to be usable by people who have only like a basic knowledge of C++. Next, I care about safety and testing. Right? I often think about this in terms of digging a pit of success. We should really strive to avoid gotchas, like dangerous things that would be sort of the obvious but incorrect way to use the library. And lastly, I care about development speed. This obviously has to be on the list because that's one of the problems that we identified. It's the reason we're actually attacking this problem. But I think it's just like generally important, right? It makes everybody's lives better. There are 3 things I want to call out about this list. So one is performance is not on this list. And it's actually not that I don't care about performance. I do quite a lot. But sort of all of the examples that we're going to look at, performance isn't an issue. Maybe the overhead is an extra function call that's going to get optimized out anyway. And so sort of I wanted to mention that like, yes, performance should be on this list, but for the purposes of this talk, since the performance is all the same of all the libraries we're going to look at, there's really nothing more to say. Second, this list is ordered, right? It's not a bulleted list. There's actually numbers here. And that's because I think that evolution is more important than development speed. And what that means is that when we're faced with a trade-off, where we can maybe make the thing a little bit faster to use, a little bit easier for our users, but it's going to lock them into certain specific use cases, I'm going to choose not to do that. I'm going to choose evolution over development speed. And the last thing I want to say, I think, is the most important here. If you were listening carefully, I used a lot of I statements. Right? I actually don't claim that these should be everybody's design priorities. I really don't think they should be. There's a lot of space for different libraries you could design and different reasons you might want to use a library. These are just mine. Right? I'm not even going to defend why they're mine in this talk. If you disagree with these, I would love to talk after this talk, because I'm just curious on what people are sort of motivated by. But for the purpose of this talk, I want to take these pretty axiomatically. And the reason for that is the ideas here are sort of independent of any particular design priorities, right? If you have a different list here, or maybe development speed is more important to you than evolution, that's fine. You're going to design a different library, but this whole process still makes sense. OK, so we know what the problem is, and we know what our priorities are. So now we can start actually exploring the design space. So what techniques can we leverage to solve this problem? Now, I by no means have an exhaustive list here, but I can think of 4 techniques. I'm going to cross off code generators as an option right off the bat. And the reason for that is that code generators are really hostile to large-scale refactorings. And that is like the primary tool I have for doing for evolution. And since I care about evolution, right, I just have to cross that off the list. Beyond that, code generators, they solve the problem for code writers, but they don't really solve anything for code readers, right? There's sort of 2 ways you can manage code generation. One is you have a tool that generates the code and you check that into your repository, in which case readers have to read all the boilerplate that you didn't want in the first place. The other option is it's part of your build step, right? And then it doesn't show up at all. And now readers, like, you have an understandability problem, right? Because readers don't get to see where this stuff came from. Makes it harder to debug and all of that. So I'd like to avoid macros. macros are just another form of code generator. They're one built into the preprocessor, and they have all the same problems of sort of understandability that any code generator has. I'm still waiting on my acceptance letter to Hogwarts, so actual magic isn't going to cut it for us. And that leaves us with just mixins as a solution, right? Now, that's a slight lie. Real, honest-to-goodness language reflection support would be super helpful here. But we don't have that yet. So maybe C++ 26, 29, we'll get that. But for now, we are really stuck in this world where mixins are the solution. And so this is what I mean by sort of exploring the design space, right? There's tons of options for solving these problems. And if you had different priorities, yeah, maybe a code generator is the right way to go. But for our priorities, right, mixins are sort of the best solution here. Okay, so if we're going to be using mixins, we should understand what they look like, both in C++ and in other languages. And so let's start by looking at mixins in Python. Here's an example of a mixin. Same idea, right? This class person with the name and the email field. And we have this equality mixin, and it's implemented as a base class, right? That's the person, paren, equality. That's how you specify base classes in Python. And you can see that this implements equality by comparing the underlying dictionaries for these objects. So Python being as dynamic as it is, the base class has access to all of the derived fields. And so comparing these dictionaries, in the dictionaries, there's going to be a key for name and a key for email. And comparing them will actually do the right thing in this case. The important thing to point out here is that this functionality of equality is mixed in to the person, but it's actually defined without having any information about the person, right? Equality is defined once in some library that you import, and then you can mix it in, and it will work with any class that you mix it into. So here's this one's maybe a little bit smaller and hard to read, but this is a mixin in JavaScript. It's largely similar. JavaScript has a slightly different inheritance model than Python. But it's pretty similar. This is a two-string mixin, and so we're going to iterate through the properties. JavaScript has, the properties include all of the member functions that are there. So we're going to ignore those. We don't want to print them, but otherwise we're effectively reflecting on whatever is in the class that this mixin gets mixed into, and we're going to print out all of those properties. And again, the important point is that happens without actually knowing what class it's mixed into in the first place. And then it's only later that you associate those two things, right? So that's sort of the key idea with mixins. It's not necessarily about inheritance, but the mixin gets defined without any association with the class it's mixed into, and then it gets associated later. Okay. Now, so this is a C++ conference, right? So we have to talk about what mixins look like in Rust. So this is a mixin in Rust, right? And this is a totally different model for mixins. This is this derive macro. Now this one, derive EQ, happens to be one that's built into to the Rust compiler, but it doesn't have to be. You can write your own. And what you get when you write your own is a token stream, and you have to return a token stream. And these token streams are, they're a little bit more complicated than just I get the struct keyword and then the person identifier and then the open brace. There's actually some sort of tree-like structure there. So you have a stream of tokens, but you sort of have an AST already parsed for you. But you do have to sort of iterate through those and then say, okay, I'm going to track. I see I have a name field and an email field, and I'm going to emit those out because I don't want those to sort of disappear from my class. And I'm going to add in. Now that I've tracked all of this, I'm going to add in equality that's going to compare all of those fields. Yeah, Daisy.
Does it bother you that some of these languages, many of these languages, are using the same mechanism for mixing in functionality that they use for establishing is-the relationships?
Yeah, it's a little bit strange, right? In the case of Python or anything that uses inheritance here, it is weird to typically you use inheritance to say this is this thing derived is a base, and it doesn't really make sense to say person isn't equality. I think there's a way you could phrase it. Person is a thing that has a quality. And so if instead of eq, you referred to it as thing that has eq, maybe that makes a little bit more sense, but it is a little bit strange, especially in a world where, you wouldn't ever pass around like an equality object.
This is why I've mostly seen people not use inheritance for mixins in Python.
Interesting. I'm certainly no Python expert, and so I'm curious to see what other ways to do it in Python.
We mostly use decorators.
Use decorators. Okay, yeah. So I guess decorators are, I don't know what the equivalent is in C++. Maybe attributes if you could actually code them, but you can't really do that. So I don't know. Maybe more things to explore for the future. Yeah, Z. Code gen? Yeah, I guess you're right. Decorators are code generators in some sense. So there's no inheritance relationship here is sort of the key thing, right? That you can do mixins without that. And the last one I wanted to point out is actually we have mixins in C++. Operator equals, not equals, right? Spaceship. This is a form of mixin. The definition of equality here is baked into the compiler, baked into the language, and it's mixed in. It's associated by writing this equals default line, lines 5 and 6. But this is, in some sense, a mixin. The problem is you only get to mix in the things that the language defines for you, right? You only get to mix in equality or spaceship. You can't do that with a specialization of std hash until we get sort of language support for that. Okay, so I want to explore a few mixin libraries in C++, because even within the language, there's a large design space here. And one of those libraries is going to be the library that we designed, but we're not going to start there. So we're going to start with a library that has been used internally at Google for quite some time. It's called Tuple define struct. If you are familiar with Boost Fusion define struct or HANA define struct, like it's very similar. That's sort of where it comes from. The key differences I want to point out, actually there's really just one, and that's this inside the tuple define struct macro, that second field is a list of capabilities of what your struct is able to do, right? And so eq says you're going to get equality generated for you. Any is non-equality stream, like an ostream operator, and you can specify these. They're baked into tuple define struct, right? So you can't really add your own. But you can, like anything that tuple define struct knows about, you can add one of these little keywords and you get that generated for you.
Isn't that a macro?
Yeah. So this which part, like the tuple define struct? Yes, this is a macro.
You crossed that off your list?
Yes. This is not the library that we designed. This is one we're replacing.
This was the problem.
This is one of the problems, and we'll take some time to dig into like precisely why this is a problem, right? Like articulating exactly why this is frustrating to use. So another one that I think is really worth calling out in this space is BoostPFR. This thing is really cool, right? Like if you look at this, like this is almost exactly what we want, right? We said that all of the stuff other than person, name, and email was sort of noise and not important, and there we go. We got rid of all of it. So BoostPFR functions for takes the name of any struct that's an aggregate, and it does some pretty fancy reflection stuff to sort of extract those fields. And then once you have those fields extracted, it can generate equality for you. And so BoostPFR functions for hides generation of operator equals and comparisons and hashing and all of those things. So yeah, everything is sort of handled for you in this one macro. So then there's a library that we've designed. It looks like this. This is the usage for it. And it's sort of, it's modeled similarly to tuple define struct, just without macros. And what I mean by that is you list the capabilities explicitly, right? So this, the base class here is intended to be read sort of like a sentence in English. So we say, we have this person struct, and we're going to extend person with equality and printing. And so this person here will be comparable for equality, and you will be able to print them like with an ostream operator. And you can just add more extensions if you want. Extensions can be user-defined, right? We don't have a built-in JSON extension, but you could define your own and you could put it here. So we'll give some examples of how to do that. And the other thing I think that's really cool here, actually, if you look at this, there's, in my opinion, a little bit of a code smell. We have an equality extension. We have an ordering extension, right? Ordering here means like the lexicographic ordering. So first compare the names, then if they're equal, compare the email addresses. But if you have the lexicographic ordering on all of your fields, you have equality automatically, right? Like it has to be there. And so you shouldn't have to specify it, right? It should be implied by the ordering extension. And so we made that work. You can just drop equality and you get it because the ordering extension says, hey, I depend on equality. And so if you ever use the ordering extension, you automatically get equality as well. So another thing you can do with this is it doesn't just work with aggregates the way Tuple define struct and BoostPFR do. You can have this in a class and it looks a little bit wonkier. The two things I think that are worth pointing out, one is we can't count the number of fields that you have automatically, and so you have to tell us. So on line 2, it says extend person comma 2. That 2 is the number of fields that are in this class. And then, of course, you need to give us access to that, and that's what this friend enable extensions does, right? So that gives all of the extensions access to the field so that I can actually generate equality properly. So this is what it looks like to write an extension. So this is the equality extension that's built into the library, but if you wanted to write your own, it would look like this. So once again, there's some curiously recurring template pattern thing going on. But the idea here is you have a template. That type T is the derived class that the mixin is going to go into, right? And so if you want to generate equality, you need to implement operator equals and operator not equals. These are going to be findable via ADL. So we have not equals, and if we just had this, this would be a very complicated way to try to write equality, and we haven't actually given you a way to get access to any of the fields, and so you wouldn't be able to write anything useful. And so there is one more piece here, which is the unpack function. So unpack effectively takes your type, and it returns for you a tuple of references to all of the fields in your type. Right. So here we're relying on the fact that equals for std tuple actually does the right thing for us. Right? And so this is going to compare all of the fields, and that's what equality looks like here. If you want something a little bit more complicated, like say you want to write a serialization extension, you would again add the methods that you want here. Sorry, the functions that you want here. They could be member functions. They can be free functions, whichever you prefer. But we have them as free functions here. And the common pattern is to unpack, so you get a tuple of references, pass that into std apply with a lambda. So now you have a variadic pack of references to your fields, and then you typically fold over that pack, right? And so in the first example, we're serializing each of the fields, passing that to the folding over the comma operator. So it's going to serialize the fields one by one. And then for deserialization, we're folding over the logical AND operator. And the reason for that is, right, deserialization could fail. And if that ever fails, we want to sort of exit early and return false. But this is the common pattern for implementing these, is to unpack into std apply. And then the last thing I wanted to mention here is, I said that extensions can have dependencies, and you do this with a using declaration. So you have using deps equals a type list of all of the extensions that you that you want to apply. And so in this case, the ordering extension implies the equality extension. So in the ordering extension, you would implement less than or equal to, but you wouldn't implement equality because you're depending on that. Okay, so this is like 3 libraries in this space, right? One of them is the library we designed, and there's a ton more that of design space in terms of reflection and mixins that I just don't have time to go into. And so I'm going to give you some homework. These are amazing talks, and you should watch all of them, especially if you're going to design your own mixin library or reflection. on the slides, like these are actual links, right? So you can go and watch all of them. But yeah, like there's a lot of other things here. You know, I said we're not going to talk about we're not going to do this with code generators, but like there are solutions here with code generators, and so you can look at what other people have done in that space. Yeah, Pete.
Are you going to unpack the unpack function?
Yeah.
Am I going to unpack the unpack function? I'm not, because it is done in actually a good chunk of these talks. In particular, a talk of daisies. So I'm happy to talk about it like after the talk about how it's done. But I think if you want a really good explanation, you should ask Daisy how it's done, or watch her talk.
That's the C++ North one, by the way. I did the mistake of naming a bunch of different talks the same thing.
Yeah. Yes. That's. Yeah. Yeah.
So, if the functions are not free, they have a problem with like overloading, right?
If they're not free, they have a. In what
If
sense?
they are methods, and you can't overload the same name, right? Because then it would override the mixin.
You can't. That's right. Yeah. So if you happen to like, because these mixins are going to be, you know, sort of hierarchically like in a base class, if you end up defining a mixin with the same name, you're going to run into a problem. Like it'll choose yours rather than the base class.
Even if the signature is different, like so how is there any solution to get around that?
So we don't have one of those. Typically, the answer that we give is like, yeah, try to do this with free functions. And in the last like couple years that we've had these, I've seen something like 20 or 30 different extensions that people have written, including the sort of core ones like equality that we provide. There are very few that actually add member functions. It can work. You just have to be more careful. And yeah, that's definitely a potential problem. Yeah.
For some of your mixins, let's say equality, not every field in a class is used for quality. Do you have a way of sort of saying don't pick certain fields, or excluding them from the equality or ordering?
So if you want this generated for you, then you get the equality generated for you, right? And it's going to compare all the fields. If you don't want that, then you probably don't want to be using this. The problem here is, I guess, if you want something like operator, you want the ordering, but
Timestamp field that really doesn't, right? I'm never expecting it to equal, but the other ones I do.
then, yeah, I mean, from a design perspective, I would say you probably don't want to generate equality if you have fields like that. I mean, I guess the short answer is like, no, we don't support that. But yeah, Z.
I have checked the code, which is absolutely right. But I remember I had to hide a method like that. You can make the method private and then use a delegate pattern, and that will allow you to hide the method. But then you can only see it in that class, and that's what you want to do.
So by the delegate pattern, like how would it take any variant of the parameters?
Why don't we talk after?
Sorry.
Cool. Yes, love it.
We're going to answer Peter's question. That's an intentional design decision, right? Because you want to limit the cognitive load of a mixin like this, especially across a very large code base. And so if you allow it to mean too many things without being explicit, if you have too many shortcuts, right, then the cognitive load of the entire mechanism becomes larger. And so not allowing that kind of use case and requiring you to write the boilerplate out for equality when you don't use all of the fields is an intentional design decision.
Another way
Do it.
Another way you could do this is if you have that timestamp field, you could wrap that in a I don't really care about equality template that generates equality and always returns true, and then equality works for your thing. Right? Like I don't love that pattern, but like it's a way you could do it. Yeah.
I was just kind of curious. Unfortunately, I also haven't seen Daisy's talk, so I'm missing the main trick as to how this works. But I will definitely watch it. But I'm just wondering, what's the actual compile time hit for this?
Yeah, there is a compile time hit. It's not as bad as I would have expected. In particular, when we were designing this, right, we went through this process, and this was a concern. Like, you're doing a lot of stuff with templates. Like, how long does this take to compile? And it's it doesn't seem to be that bad. I don't remember the numbers offhand. But one of the things I do remember is that this was about 50% faster than the tuple-defined struct. And there's a slight asterisk on that, which is tuple-defined struct, like you would expect the macro to be much faster. And the reason it's so slow is because it does some stuff to like extract the field names and throw them in a variadic template of like a variadic pack of characters. Because it's, you don't need to do that anymore. Like as of 14 or 17, that's no longer necessary. But it did it, and all I needed to prove was, hey, this is better than the thing we're replacing it with, even if that thing could have been better too, right? Yeah, this hasn't actually been an issue for us in terms of compile time, but you could imagine if you have, if you're doing you have a large number of fields, or the graph of dependencies of your extensions is deep, like that could be problematic. Okay, so we looked at a bunch of designs for mixins in other languages and in C++. And at this point, right, it's not enough to have just designed something. We want to actually grade our design. Like, how well did we do according to our design goals? And this is why it's important to have the rubric ahead of time, right? So we're going to grade this extend library and the other ones on these 4 goals. And so I want to start by with sort of the baseline. Yes, I know this is small, but this is the write it yourself solution, right? This is no library whatsoever. And I kind of want this part to be more interactive. So we're going to grade these on a typical scale like A, B, C, D, F. This is a person, same thing, name and email. It has equality, not equality, and streaming. So what do we think in terms of evolution? What would you say? Just shout it out.
I would still like to see how you do it. Could you zoom in?
How we do which?
How you do this? Could you zoom in on this? And just make the code readable.
It's too small.
Oh, it's too small. Yeah. Sorry. Let me. Can I? I don't know if I can zoom in. I can't. There we go. All right. So there's the point here is this is if you had to write it yourself, this is what it would be. Yeah, I apologize. This is small. The rest of them, there's less code, so it'll be easier to read. But
hashing, would you make this a function or a separate class?
Make which a function of a separate class?
Hashing, would you make a class for that or just a function, a method?
For hashing, I would probably specialize std hash. But yeah, for this particular case, we're not going to do that, right? We're just going to have for these examples, we're not going to have that. Just stream in. Goes, yeah.
Some reason why you're not going to default to equal and not equal?
No, you're right. I could here. That would be
Slightly short.
It would definitely be shorter. And this is one of the things as the language progresses, right? You get this better functionality.
It doesn't need to be friend, right? Because it has no private fields.
Yeah, it doesn't need to be friend either. That's right.
No, it does because it's a free function.
I could implement it outside the class too. Yeah. But yeah, so I mean, do we have thoughts like A, B, C, D, F? What do we think? Z. C. Okay. So I gave it a B plus. Let me make this full screen again. And the reason I gave it a B plus is if you have to add a field, right, it's annoying, but it's at least scoped to a single file, right? I can make all of the changes locally, so it's doable, and without a huge amount of effort going across many different translation units. I can also I can change this to a class without much problem, right? There's that. What about understandability?
I kind of fall a little bit more on Z side on on the evolution, because if you want your stream operator to consistently across multiple of these have a different format, not using a mixin makes applying that change globally require substantially more sophisticated techniques.
Yeah, that's a good point, right? If I want this format of person, bracket, and then all the fields, I can't do that uniformly. So yeah, that's certainly a thing. But you know, if you only care about like I would like this for like debugging purposes, so that it prints out the information that a human can look at. That's sort of what I was aiming for here. But yeah, these are all sort of subjective grades. So in terms of understandability, I actually give this an A+. I don't think you can do better here because you know, this is all stuff that somebody like that just comes out of university that has, you know, had a course or two in C++. Like this is how they would implement it, and so they understand everything that's here. What about safety and testing? Come on, shout it out. A? I think we disagree. I gave this a D. And the reason is, like, if I want to actually make a change here, I have to remember to change all the fields and to test all of those, right? Like, I have to test them all myself. You know, it's easy to forget them or order them incorrectly. And you know, if you order them incorrectly or if you forget a field, okay, maybe like your equality is wrong, you'll catch that. But what if you forget, like in specialization of stood hash, right? If you forget to have a field there, now you're going to get a lot of hash collisions. And if an attacker has control over that, they can take your linear time or your constant time, you know, constant time algorithm and turn that into a linear time thing, and you have a denial of service attack.
Yeah, but you didn't show hash.
I didn't show hash, right? But like, yeah, you're right. I didn't show hash on this one. That's fair. But like you see like similar sorts of problems through all of these. So, and then development speed, like there's just a lot of stuff here, right? So I don't know, C-. Again, all of these are subjective. You don't have to agree with them, but yeah. What about BoostPFR? Thoughts?
You're fixed, right? You don't have. You just get a certain set of functions, and that's it.
Yeah. So you only get a certain, like you only get the things that BoostPFR has defined for you, right? You can't add these extra capabilities.
Easy to add a field, right? So it's easy to evolve the class.
So it's easy to add a field. It's not easy to add a function. It's not easy to change this from a struct to a class, right? If I want to make this a class, I have to give up on BoostPFR. Or even if I want to add a constructor, right? Then it's no longer an aggregate, and so I can't use any of this anymore, and I have to go back to writing it all by hand. So again, all subjective. I gave this a C. That might be a little harsh, but that's what's in the slides. Understandability?
B. It's a C. You gotta know what PFR does, right?
Yeah, I have no idea what that macro does.
Exactly.
Can we go F?
So this is fascinating. So I heard like C, D, and F. I actually gave this an A-. And the reason I gave this an A- is like you're right. Like it can't be an A+ because you have to understand what BoostPFR does. But in a world where like this is common in your code base, you know, you learn what that does once, and then okay, that's an idiom. And so it doesn't actually seem that bad from my perspective.
It's 2023. Macros should be.
Like yes, we should get rid of macros if we can.
Not till 2026 with reflection.
When we get reflection, any day now. What about safety and testing?
I'm assuming that their tests are well done. I'm going to say an A, right?
Yeah, so right, assuming that this library is actually tested, and like spoiler alert, it is, like very well, then yeah, A+. Right? You don't have to write any tests. You get equality and it's correct. Like, no worries about that. And development speed, like I don't actually think you could do better than this. Right? Now, like looking at this, okay, so we had some disagreement on whether or not this is understandable, fine. But I think here, it's important to clarify that evolution wasn't a goal for BoostPFR, right? Development speed was like the primary goal, and they've achieved that. So tuple define struct, thoughts? I see Z is like thumbs down on this.
Unknown macro. Can you add new functions to the macro?
Only if you like submit a pull request to the, yeah, so basically no, right? It's the same deal as BoostPFR. You can't add new functionality in that way. And you have the same problem of this only works for structs. You can actually add constructors in this case, so it's not just aggregates, but yeah, you're basically stuck with it being a struct where everything's public. And so yeah, I gave this a B-, because I think it does slightly better than BoostPFR on evolution, but it's not great. Understandability. Yeah, I see lots of thumbs down. I gave it a C-. This could maybe be a D. I don't know. Again, in a world where this is used, lots of times, like people become familiar with it, they see this pattern, but there's a lot going on here. In particular, like this macro is very magic. I don't know, once a month or so, we'll get a question like, why can't I put a stood pair inside a tuple-defined struct? Right, and then we have to explain that like you just need extra parentheses because macros don't understand angle brackets and all of that. So for somebody who's like, basic familiarity with C++, there's just a lot going on here that they have to understand. But again, safety and testing, I think is great, same reasons, right? And development speed is not the worst, but it's not the best either. Okay, and you don't have to be too kind here, but like honestly, what do you think in terms of like evolution for extend? I see some thumbs up. I gave it an A. I mean, I was involved in the design here, right? So maybe I'm a little biased, but I think that this does well on evolution because you specify exactly the things you want, right? And what that means is that if you ever want to add a field, you're not like, I guess I didn't mention this, but with BoostPFR, one of the problems is you get everything, whether you wanted it or not. And so if you want to add a field that doesn't support hashing for some reason, but somebody already put your thing in an unordered container, you're kind of out of luck, right? You're going to break them or something bad's going to happen. And so for these where you list the capabilities explicitly, the benefit is you're only getting the things you asked for and only the things that you really want. This works with classes too, right? You can add new extensions. So all of those sorts of things that you might want to change over time.
Just like you did with the original, you said, well, you could forget to put the hash function in, but you forget it here and cause problems too.
So if you forget the hash function here, then it won't be hashable. But you can add the hash function, right? And then
Compile time error?
Yeah.
Will it be a compile time error if what?
No hashing, if you didn't have the hash function.
If you try to hash it.
If you try to hash it, and yeah, then that'll be a problem, right?
Well, we've had the same problem with the plain struct in the very beginning, the beginning example.
I think that example, the implication was that hashing wasn't necessary for that class, right?
I think you were talking about forgetting to add a member
You said
variable
forgetting
to
to
that.
add-
Yeah. Sorry, I don't think I described this well. If you have a hash implementation or you have an implementation of any one of these, and you add a field but forget to mention that field in your equality or in your hash, that's what I was saying. Yeah. So where are we? Evolution. Yeah. So understandability. I've given this in A-. I think that it's nice that there's no macros. There's functionality that's a little bit strange, and like how this actually works under the hood is definitely magic to most users.
They're descriptive though.
They are.
And with.
They are descriptive, and I think the important point is that users are already familiar with inheritance, and they're already expecting that some functionality might be hidden inside a base class, and the functionality that we're hiding is listed where we would list a base class, so you sort of know where to look. Safety and testing is the same story as the other two, right? It's like also it's all tested for you, and then development speed. Just based on what we've seen in practice, like this is better than tuple-defined struct for most users. Give it an A.
Question on you were saying safety and testing. That's only because strings are well-known types with these. If you were to include your own type, it would not be well tested because you would have to prove that your own type was tested.
So I would call that a like if you have your own type that has its own equality or its own member functions, any functions that are called, you need to test that type, right? But that's sort of separate from the extend functionality. So the testing there is the question of like, does this correctly generate equality for you up to its specification, which is to call equality on each of the things. And so I think it does that, and that's well tested. But any specific field you do have to test.
And not on fields, if you add your own extension to this, right, you don't know if it's tested well or not.
That's right. But the testing there's like for the extension rather than the use of the extension, if that makes sense.
But that's the same thing.
No, so like I don't have to write the equality extension to use it.
No, but I'm saying you put your own, you need a particular extension that's not general.
Yep.
So you write it because you have a couple of classes that need it and you want to use it as a mixin. That particular is just whatever you test and you did in it, right? It doesn't get the wide use that printing and equality would get, so they would be much better tested.
Yeah, I mean, I guess printing and equality are better tested because they're like part of the library and we actually tested them.
I may have missed this, but for your equality, do you have weak ordering?
No, this is equality is compare all of the fields like in order. Yeah.
There's only a strong ordering mixin. I don't think we've implemented a weak ordering mixin.
We have not implemented a weak ordering. Yeah.
I'm just curious, are you gonna show us what the extend class looks like or the extension class?
Yes.
Okay.
In about 30 seconds.
Okay, cool.
So yeah, I mean, I think the main point I wanted to make here is actually like, right, stepping back to this, like the design parts of this, like, okay, so extend did best out of all of these, right? It got all A's. This might seem unfair if you're like, Andy, like, yeah, you came up with the design goals and then you designed a thing that matched your design goals, right? Like, and you're totally right. Like, this is 100% unfair, right? I made the game and then I won the game. And like, that's to be expected, right? Everybody else was not playing this game or didn't know that they were playing the game. And I think that's the important point about setting your design goals up front, right? That's what you want to do so that you always win the game. And it's not that the other things are bad in any way, right? It's that they were playing a different game, right? BoostPFR was designing with a different set of use cases in mind. And if the authors of these other libraries were up here giving a talk, they would have a different set of goals, and they would win in their game, and like that's great. So, yeah.
Do you think it's understandable for a user to say, for example, I want to derive from this structure. I want to extend it, add some stuff. Or if it was
like
I want to derive from this class.
To derive from the class, yeah.
Members and so on. Do I understand upfront what is the implication about the extension?
So it's a good question. I don't think this is any different from inheriting from a class that defines equality, right? Where you need to be careful because you're getting equality for the base class, but not any of the fields that you add. Now the question of whether or not that's understandable to a user or a user is going to think that equality works on their subfields, I don't really know. We haven't seen much of that. I haven't seen complaints about that particular issue or like bugs related to it. So just like practically, it seems like people understand that well enough, but I don't have sort of a theoretical answer to why it's okay. Yeah, Chris.
If you were to derive from person, and then you wanted to extend that class, you'd have to use a multiple inheritance, and then are you going to have any conflicts between the generations of the extend, or are they just going to kind of inherit each other?
I haven't thought about this deeply. I think it will be okay, but I'm not. I think you can hide those. Yeah, Daisy, do you know?
This is a known problem with mixin pattern across multiple languages. Is that mixins and inheritance hierarchies don't particularly play well together when you try and mix it in at multiple levels of the hierarchy. So this is like not an issue with Andy's thing. It's an issue with
not my thing,
pattern.
to be clear.
Right.
Like this wasn't just me. Did you have a?
I would just like to add for the question that was asked about if it's understandable. In my opinion, it's clearer to read something like this than to read a macro. What the macro does? Macro is magic, it's generating code, and no one understands it. The only problem here is because you're using templates, so people will be afraid of it, and that's it. But expressiveness is there, so it's you read it and you understand exactly what you're doing. It extends with those things.
This is pretty magic too.
Silly question.
Yep.
Different things.
What happens if you don't say with, you just say extend person?
Compiler error. Yeah.
Cool.
Is there another? Yeah, Dan.
Just in case I wasn't the only one wondering what PFR stood for, precise and flat reflection.
Cool, thank you. I knew that at some point, but I, yeah. Okay, so I said we were going to talk about the implementation. So we're going to talk about the implementation, switching gears a little bit now. This is effectively the implementation, right? So we have this struct extend, it's final, so this answers your question like, what if you forget the with and you just try to extend from extend? Compiler error. This extend is, like, there's nothing in this class at all, except this nested struct, right? We're sort of using extend as a template namespace, if you think about that, right? Just to like, it's a namespace where we're going to store the with, and it's going to stash that type T that we're inheriting from. Or we're having as a base class of. So there are, I think, 3 things worth specifically pointing out here. So one is the field count, right? You don't need to specify it. -1 says we're going to try to count the fields for you. There's this dependencies thing, right? Remember that extensions can have dependencies, and so the list of extensions that you give us isn't actually the list that you're going to inherit from. So we're going to do this computation. Given the list, what are the actual extensions that you care about? And then lastly, this extension set. This is just like allows us to do the inheritance that we want. Yeah.
Just a question. So here you're expecting that the extension will have just one template parameter.
Mm-hmm.
Why just only one? Maybe I want an extension with 2 template parameters.
Just one because that's all we've needed so far. I suppose because this is like the template thing, you could have this be like a using declaration that bakes in, like a using alias that bakes in specific template parameters. But yeah, we haven't thought about like what if you wanted extra things there. I'm not exactly sure I know how to do it, but if you have ideas, I would love to talk about this afterwards. Kristen.
Can I ask a very basic question, not for me or anything, but for the people and watching the recording?
You can ask for any reason.
Can you explain line 3?
Line 3.
It's a little confusing.
Sure.
All the templates.
Yeah. So this is like a right. Normally, you're probably used to seeing like template type name T. But you could also have like template int n, right? You can put types in there. You can put integers. You can also put templates in there as well, right? And so if you want a template that is templated on another template, this is how you spell it. So like you could put like stud vector in there, not stud vector of int, but stud vector. That wouldn't work for extensions, right? But that's the like when we talk about templates being put in here, that's the syntax here. Yeah, Daisy.
So if you wanted to support arbitrary number of template parameters to the extensions, you just put a ... after the type name in between the inner angle brackets.
Right.
I did that on this, and I don't think I ever got around to submitting it.
Why not?
It takes a lot of time.
Yeah.
But also the reason why they haven't done that yet is because they've only ever written their own extensions, and their own extensions all have one.
But basically my question is, if it would use the variadic class, you could do it with one or many. So it wouldn't harm you to do it.
Wait till you see what the one template parameter is, and I think it'll make a little bit more sense.
Yeah, it's not like you could certainly have this take things that are variadic. I'm just not sure how you would use that later.
It has to have names, but maybe
yeah.
You can unpack it some. Let's continue.
Yeah, I think like I'm interested in seeing what we could do with this and like what problems it would solve. I believe it's possible. I just haven't thought about it too deeply.
Yeah, the other thing I'm not sure about there is that even if you did make it like a variadic template, I'm not sure if you can actually have, like in the parameter pack there, I'm not sure if you can have templates that have different numbers of parameters.
You can.
Mm-hmm. You can,
That does
yeah.
actually work.
It didn't work for a while on several compilers, long after it was in standard, but it does now in all the major.
Did you have a?
What does it mean, this type name between the angular brackets?
Like up here?
Yes.
So this is the question Kristen was asking as well, right? So this is it's not just putting a single type there, but it's putting a template.
Say like template bracket type name T or something else that you were going to use in the rest of this class, but it didn't.
Yeah. That could say like type name X or something in there as well. I just didn't give it a name because I'm never going to use that name.
Seeing it like that, if it helps.
You can put a name there, but you can't use that name for anything, I don't think.
That's correct.
That's
So
you have to do another hoop to jump it.
So okay, so right, this is the basic overview of it, right? How you get the extend type with stuff. In terms of extension set, right? There's not a lot interesting going on here. We have this type list of all of the extensions, and we inherit from all of them in a sort of flat hierarchy. You could think about doing this, and if you come from like a more functional background, you might think, oh, I'm going to like inherit from one thing and then inherit from the rest that inherits from one thing, and sort of a chain going up. And then you run into a bunch of problems of like, if you had two of these things two extensions that generate the same functionality, one of them is going to shadow the other. And so it's actually really important that you do this in a flat hierarchy where you extend from all of them simultaneously, because then if you have this problem, you'll actually get a compilation error. Okay, so I want to talk briefly about dependencies. This is, I think, like the sort of secret sauce that makes extend work. Right, when you're computing the dependencies, all we're effectively doing here is we're getting the return type of this thing called find all dependencies, and that's going to be a type list. And what we're effectively doing is a compile time breadth first search through all of the dependencies that extensions specify. So we're going to track this like queue of unprocessed types. That's the first parameter here. And we're going to start with an empty list of process types. And we're going to one by one peel them off, process them, and put them in the list. This might be a little small in the back. I apologize. I'm going to go through it. I think the main takeaway here is sort of an aside from the main talk, which is this kind of looks like how you would write a recursive breadth first search, not in Const Expr. And I think that's a real testament to like the improvements that Const Expr has had in the last decade. Right, this is almost what you would write in like sort of normal code. So how does this work? Well, the first thing is if the unprocessed list is empty, right, there's nothing left to process, we're just going to return all the things we've already processed. Otherwise, we're going to split this up. We're going to take the first thing that's unprocessed, and we're going to have the tail, the rest of the type list. We're splitting those up. And we're going to ask the question on line 9, is this first type already in the processed list? Because if it is, we don't need to process it again, and we're going to recurse by calling find all dependencies on the tail of the list and the list we've already processed. If we haven't seen it already, if it's not in the process list, then we need to do something interesting, right? We need to actually process it. And here we're going to ask, like, does this first type have any dependencies? Like, are there any dependencies specified? If so, we're going to grab that type list, we're going to append it to the tail, and we're going to recurse. So we've taken all the dependencies that may or may not have been seen before. We're going to process them on some later iteration of this. And then lastly, like if it doesn't have that list at all, we can just recurse normally, right? We're going to call this on, we're going to call find all dependencies on the tail, and we're going to stick the first thing in the process type list. Yeah.
So my question is, why did you decide to go with the recursion and not just trying to access the variadic package itself? You have ways to access the variadic package, and it would be faster than recursion.
I'm not. I mean, I think the short answer is no reason. Like, if we can make this work without the recursion and it's faster, like that sounds great. Let's talk after, because I'm not sure I know how to do that.
It's not actually faster unless you have 40 of these.
I think it is, but let's talk afterwards.
Sure.
Cool to see else if context for requires. I'm wondering if this is implementable in earlier editions.
Yeah, and in fact, I wrote it like this so that one, it fits on the slide, two, to have that line, but yeah, in fact, this is all implemented actually in 17, and so I think this is all doable as early as 11. It's a little bit hairier, but like, yeah, I think it's doable.
You don't have any hard stop on the recursion deck, right?
Just what the compiler enforces on us. In practice, like actually
the classes like this before, Chris Juzek had a class for figuring this stuff out, and you had this break to stop us going too far down.
Yeah, so in practice, actually, I believe there's only one extension, maybe two, in like the whole of our code base that have any dependencies like this. So it doesn't like. This is like more fun than it is like super useful, right? Like it needs to be there because like it's very important for the ordering extension, but in practice we don't go through we don't iterate through this many times.
If you have a class hierarchy of 256 things that depend on each other conceptually and are all different, you have much bigger problems.
That is fair. Yeah.
I can't think about this, but could the dependency have been specified like an extend in the extension itself, like ordering extends equality or something like?
Oh, I see. As the extensions sort of inherit from each other.
Yeah, like
I believe we looked into this. It's been several years in a pandemic since we implemented that, so I don't recall the details of like whether it could be done. I think we looked into it and we decided it wasn't a good way to do it. Though I don't. It's because if several things both inherit from like say equality, you're going to get two versions of equality in your inheritance hierarchy, and that's going to be a problem. Yeah.
You also get overload resolution issues with the friends, I believe.
That sounds plausible. I don't recall. Yeah. Anyway, so I think like the point in terms of the implementation is like this slide plus like this is just sort of a summary of all of the things I showed you on the previous slides. Like that's it, right? Total of like 30 lines. Like granted, there's more that goes on there, and I haven't mentioned unpack, for the field counting, but there's like not actually a lot that goes into this library, which I think is really cool. As I said, I'm not going to talk about field counting because I think Antony Polukhin's talk and Daisy's talk do it much better than I could. This first one is Antony Polukhin's, the author of BoostPFR. I believe this is the first time like anybody has used the field counting techniques that are in here, and so that's really cool. He goes into a ton of detail. Daisy does a great job here as well, and actually it does it in a slightly different way than BoostPFR, and it's actually the way we use in the library. And she does a great job like motivating, like if you wanted to do this, like how would you even think to get started? So that's really cool. Yeah.
Aren't you concerned about the impact of adding a dependency to an existing extension?
Adding a dependency to an existing extension. Say more.
I don't know. So, for example, you define a bunch of extensions in your library that people are using all over the place. And let's make this extension depend on some other extensions that you define.
I see. Yeah. So if you have some extension you're using, and then like somebody goes and adds a dependency, and now you get this extra functionality built in.
Which could conflict with whatever people have actually written for their stuff.
Yes, this is sort of like the general problem, right? I don't think that's specific to extensions. You're 100% right. Like that is a problem if you depend on something and then somebody adds dependencies to that you didn't want. Just like generally a problem. Here, because of the way they're specified, like it seems very unlikely that you have equality, someone's going to add in like, oh, like equality now depends on toString. That would be bad, and we sort of just cross our fingers and hope nobody does anything like that. But you're right. Like these are like real problems that that would be nice to fix. Yeah. So, well, okay. No, we're not done. Right. We're at that last step where we're actually ready to get user feedback. And there was a ton of user feedback. I'm gonna like blow through these because there's one of these that I really want to talk about, and I want to make sure I get to it. But like weird things happened with C++20. There were some issues in our field counting techniques that meant that like when we were upgrading some stuff from 17 to 20, you had this choice, like were you going to make field counting work with uncopyable types or reference types? And we couldn't have both. After the talk, I'd love to dig into it because like especially in this crowd, I'm sure somebody has a solution to this, but we still don't really know how to fix this.
I'm guessing the compiler messages are horrendous.
Understandability, right? So yeah, using extend class gives me useless error messages. This was a common complaint. And I'll show you one of the things we did to fix this. Safety and testing. There's actually not a bad bug here, but you could add an extension that you never used that couldn't have possibly worked, and it would still compile. Right? So if you had a class with a mutex and you said like I want operator equals for this, it would compile. You wouldn't actually like if you went to go use equals, it would be a compilation error. But you could check in the class without a problem there. And so we had to fix that as well. And then the one I'm really excited to talk about is the most common request we got for this thing was, can you make this print the field names? Right? Tuple define struct was a macro. It printed the field names when you printed it. Can you make it print the field names? So I'm going to skip through. I mentioned evolution. In terms of like this understandability issue, we just added a static assert for the common issue where like the most common issue is somebody converted their thing from a struct to a class, and they forgot to say what the field count was. And so we added this static assert, and this basically solved a lot of problems. So there's a nice error message here that pops up. We give an example, right? And we say like, hey, this is where the field count goes. And by the way, you probably also forgot to enable extensions. So we're going to remind you about that too. And then we have like, other documentation that it points you to. I didn't know before I implemented this that one of the items on my bucket list was to have somebody personally thank me for adding a static assert into code. But here we are. That happened. That's really cool. Safety and testing. I mentioned this about the field with the mutex. This is well, yeah, I'm going to blow through this, but we added this sort of force instantiate dependent expressions thing. This is sort of like a concept constraint, except at the time a quality extension is instantiated, T is an incomplete type, so we can't actually use real concepts here. But it sort of looks like concepts, and we check this in the constructor of the extension set, right? This is the base class that your type derives from. And so we just try to instantiate all of these. It's behind if false, right? So there's no runtime overhead here. That'll all get optimized away. But this sort of catches things earlier, catches it when you try to construct your type. Actually, as I was practicing this talk, one of my coworkers pointed out a way that we could do this actually even before you construct one of these. So we can actually like totally solve this problem. Just haven't implemented that yet. Okay, and then development speed, right? I mentioned because tuple define struct, print the field names, like that was an issue in terms of feature parity with the thing we were trying to replace. This is what the printing extension looked like sort of before we tried to attack that problem. And it's again the same problem, the same pattern of you're going to unpack into std apply, you're going to take your tuple of references, and you're going to fold over OStream, like printing all of the fields in this comma-separated list, right? And this is where we were. And then we found out about Clang's built-in dump struct. So built-in dump struct got us really excited. It's this compiler intrinsic in Clang, and it repeatedly invokes this printf-like function with information about all of your fields, both the field name and the field value. And the thing is, I am like more than happy to lie about what printf does and actually just stash the information about the field names that it gives us to be used later. And so that's what we tried to do. The problem is this wasn't terribly robust. If you try to do anything even remotely interesting here, Clang would crash. So that's not great. But then, as of like Clang 15, built-in dump struct was improved, right? Like much better testing, like to the point that we were really comfortable relying on it. When I took this screenshot, I was so happy with the top comments. I wanted to share them with you. So the top voted comment was, wait, can you do that in a const_expr function and have the string at compile time? If so, well, I have an idea for a reflection library. And then the comment under it is, yes, you can, but you have to parse the dorky ASCII output. Here's an example from the docs. And I love this for two reasons. One, this is just like a great, oh, I have this idea, like how does it work? And people coming together and like working on a thing together. That's really lovely. The other reason is I love the phrase dorky ASCII output, but like this is exactly what we're gonna do, right? We're gonna parse that. And so in terms of the extension, like this is what we have to change. So we're going to call this get field name info thing, and we'll dig into what that does in a second. And then we're just, as we do the fold expression, right, we're gonna fold and print the field names. And now you have field names. I think it's worth pointing out, though, we are not doing this like in a const_expr context. We're doing this, it's a static const for the field name. So we're using a function local static here. And the reason is we don't actually know that the type is default constructible. We don't know how to construct one of these at compile time. We don't even know that it is constructible at compile time. And so we need the user to like give us one of these to construct. And you might be worried like, hey, like whichever one happens first, that's the thing that goes into the function local static. And that's true, like any value can be passed in there, but we're not gonna look at any of the values of the struct, right? We're gonna be very careful to not look at those and just look at the field names, which are gonna be the same regardless. So that's how we make that work. So get field name info looks like this. Right, we have this array of field names. We're gonna have some parsing state that we're gonna track. And then we're going to pass that state and the field names and this field name extracting printf function to built-in dump struct. And built-in dump struct is going to repeatedly call field name extracting printf with our parsing state, the field names, which is like our output, and then it's going to also pass like the field names and the format strings to print the things. And then field name extracting printf, I'm leaving a lot out on this slide, right? But it's basically you're going to like pull out the fields that you want from the format strings that you're given. There's a lot left out here, in particular because built-in dump struct will recurse into your structs, right? So if you have a string field, actually a string is a more annoying example, but if you have like a vector field, it's going to give you like the 3 pointers that the vector represents. And you don't want that, right? You just want like the top level things. And so you need to track what's your like instantiation depth in the struct, so that you can ignore all of those and pop back. So there's a bunch of extra like state to track here. But I hope this gives you the gist of like what you would do. You have to know like the format that it uses. Yeah.
I'm just curious. So is this project Clang only, or do we have if-defs around built-in dump struct?
Yeah. So we have if-defs around this. I would love something similar on other compilers. But if you are compiling this with other compilers, or earlier versions of Clang that don't have this or don't have it robustly, it disappears and you get just like you get what you had before without the field names. And because of that, we also we don't want anybody relying on the precise output here, and so we do some Hiram's law mitigation things where we add extra white space between things, so you can't write a test that's like I expect exactly this output because we can't promise that. So yeah, so this is sort of where we are today. If you think about thinking about what's next, right? Like what's the sort of the next things that people are asking for, that like what are the next problems we can solve? Testing facilities would be great. We don't have a way to generate like nice Google test matchers for your structs. In terms of understandability, C++ 23 is deducing this is great because it removes the need for CRTP on every extension that we have today. And CRTP is one of those things that like, okay, maybe like people in this room have an understanding of what it is and how it works, but most engineers don't. And so if we can remove that, it's just like less confusion for them. We just touched on this. Portable access to the field names is a thing that would be great to have. Improved field counting, as I glossed over, but if we could have field counting either on classes or with reference types or uncopyable things, that would be great. And then lastly, I think that this makes actually a really nice basis for a strong types library. And what I mean by that is something like this. There's a lot of code here, and I'm not really going to dig into it, but the idea is you could make a strong type by specifying the underlying type and then specifying what capabilities that strong type should have, right? And those capabilities are just the extensions. And you see this, t comma 1 on line 4 here. It's because we're going to have exactly one field in this, and that's like the one type that we care about. And like defining your own strong type might look something like this, right? If you have just like an identifier, well, you want equality, and you don't really want anything else. But maybe you have like a numeric type, and so you want both equality and some arithmetic added, right? Some arithmetic extension. So maybe it looks something like this. I don't know. Yeah.
Are you not sort of straying into what concepts are doing?
Yes. This is very much straying into what concepts are doing. But the issue with concepts is you can't sort of pick at them and figure out the things that you can't pick at them and figure out how you're going to generate equality, if that makes sense. I don't think you could do this with just concepts. You could ask whether or not it has equality, but you couldn't generate equality.
Right.
Yeah. Yes. This very much has a concepts flavor to it. Anyway, with all of this, we're actually getting pretty far ahead of ourselves, right? Because if we go back to the beginning of our talk, this is the process that we should be following, right? And maybe you know what problems strong types are solving, but at least in this talk, I have not said why are not having strong types a problem, and why is that a problem that's worth solving, right? What are our priorities going to be for designing that sort of thing? We have to do all of that before we actually get to the implementation, even though that's kind of the fun part. So that's basically what I have to say. So yeah, thank you. Yeah.
Just wanted to quickly highlight something. Could you jump back to 63?
Yes.
Thank you. I might be behind the times here, but that is the best comma separator implementation I've ever seen. That doesn't do the dreaded if we're not doing the first thing, please put a comma. You get it.
Yeah.
Well done. Thank you for that.
So
worth the price.
You're welcome. I have a note in here as an aside, and just based on timing, I was I have to skip this. But now we have a couple of minutes. So yeah. So the stood exchange trick here, not my own thing. I learned this from Sam Benzikin, whose name was on the slide earlier. His name appears a lot on somebody that does clever, awesome things. And yeah, the idea here is you start with a separator that's the first thing that often it'll be empty, but in this case we have something at the beginning, and then stood exchange. So every time you go through, you write that comma into the separator, and so the next time through, right? So this is branchless, but yeah, it's this works also it doesn't have to be a fold expression, right? This can be a normal loop as well, and this is it's a technique that makes me happy. So, yeah, Daisy.
So 2 comments. First of all, yeah, Sam, who I assume came up with this partially, is the person one of the people at Google I ask metaprogramming questions of. So for those of you who know me and my talks, that should say something about Sam.
I love Sam.
Yeah. Secondly, I think this is a perfect example. This dump struct. It's a perfect example of we don't need good reflection to do things. We just need anything.
100%. Yeah.
Right. this dump struct could be it, and we could make huge libraries of all kinds of amazing things. And Rust has figured that out, and we have not.
Yeah, and this could, right, like, it doesn't even need to be standardized. Like if all of the major compiler vendors, if all of the major compiler vendors implemented something like this, we would get a standardized version. But we just need like something like this. So.
Yeah, I mean, Rust macros are this bad or worse. And
I would say much worse. Yeah.
I mean, are we saying it's really just down to the list of fields? Is that it? That's really all we need?
That would be a start.
I want more, but like, yeah, let's start there. Yeah.
But let's not leave that out of the standard because we want more.
Yeah.
Pete.
So getting away from the technical template stuff, what's the adoption of this been like? Have you been able to track? Just you or people close to you?
You should go to Z's talk. I will spoil it a little bit.
I have the graph right here.
Is it in your talk?
Yes.
Okay, then I'm not going to spoil it. Go to Z's talk. It's the answer to that is fascinating, and good. Like,
how are you tracking people just not using mixins versus the ones that are? In other words, is it just pervasive? So the farther you get from Z and U, the less it's used, or it's.
We have more visibility into our code than you do.
Like I can yes. I know, like I know precisely the number of uses of this and the number of uses of tuple defined struct. Other random things like I could count, but for these two particular things, we have tracking of like exactly how many uses of it there are, and there's a lot. Yeah.
So you were saying that with concepts you can't generate equality. If you had a free function that was template on the concept of like has equality, I'm not sure if you could, like, if you had unpack, could you just make this for a number of these? Could you just make them free functions on templates, on template concept?
So
using the wrong terms.
Yeah, I think. Correct me if I'm describing this wrong, but a thing you could do is you could have an operator equals that is concept constrained on does not have operator equals. No.
Yes.
Okay.
And such that its members have.
Sure. Yeah. Such that we could actually generate it.
Yes.
I am horribly terrified of stateful metaprogramming, and this is what that is, right? At the time you instantiate it, it didn't have equality, and then we have equality, and if you ask later, all compilers will lie to you about whether or not it now has equality.
Think you could put something into your class saying, I want the free, I want to participate in this concept, and under those cases you would not have to check does it not have equality?
Yeah.
And it would be a different mechanism from Mixins. I don't know if it would be a better mechanism.
I believe this is what BoostPFR does, right? The fact that you have this macro, right? Like normally it doesn't generate equality for you, but if you add this macro with your function name, it says, oh, cool, you want equality for this thing. So like, yeah, I don't know if it's actually generating them right then and there, or but it could do that. There were a bunch of questions
I
here.
had a response, but
Oh.
I'll do it offline.
Okay, cool.
I was just curious what kind of extensions you have. You mentioned hashing, equality, printing. Are there more?
Yeah, so actually, for reasons I'm happy to talk about later, hashing is part of equality. Those are really like fundamentally the same concept. We have ordering. We have it's actually called debug-printing, but it's printing. People have done some interesting things with trying to make like structive arrays style things out of this, which is kind of cool. People have added extensions that don't add any features, but ensure that your type has no padding. And yeah, there's we have some for serialization and things like that. Yeah, this is Google, so we use protobufs instead of JSON, but we don't have. I guess with protos you have to specify the format, the schema ahead of time, and so we don't have an extension like that. But for serialization, mapping this like within the same process or to the same binary elsewhere, like can make that work. Yeah.
So C++ 20 of course has format, 23 has print. those require you to specialize the template. You can't do that here, or you can? Because this is part of the class. Right?
Yeah.
It becomes part of the class.
I think we don't have anything like that, so I'd have to actually like try this. But I think what you do is you would add something in the class that says like, hey, please generate this for. I guess this is the same approach he was talking about. You add some member that says like, I would like this generated, and then you specialize it on anything that has that alias inside your class.
Use a tag or and a concept that partially specializes on the buttons of the tag.
Okay. That makes sense.
Cool. Thank you.